All right, so today we are going to go over chapter 7, which is talking about electricity, electrical safety. So we're going to start on page 183. Explain electricity and electrical safety. All right, so you decided to enter this field because you love beauty and wellness and all of the services it offers to clients, from hairstyling to hair coloring to facials, massages, and nail wraps. How many of these services could you offer without the use of electricity? As you study this chapter, you will learn how important it is for beauty professionals to have a basic working knowledge of electricity. So, beauty professionals should study and have a thorough understanding of electricity because, us as beauty professionals, we rely upon a variety of electrical appliances, you guys. Knowing what electricity and electrical safety devices are and how they work will allow professionals to use their tools wisely and obviously safely. A basic understanding of electricity will enable, them to properly use and care for their equipment and tools. Electricity use impacts other aspects of the salon, spa, or barbershop environment, such as lighting and the temperature of heating tools. It impacts all of the services beauty professionals offer to their clients. All right, outline electrical therapy. If you look at a lightning on a stormy night, what do you see, are the effects of electricity. If you plug in a poorly wired appliance and sparks fly out of the socket, you will also see the effects of electricity. You're not really seeing electricity. However, instead, what you are seeing is visual effects on the surrounding air. Electricity does not occupy space or have mass, meaning weight. So it does not matter. If it does not matter, then what is it? Electricity is the movement of electrons from one atom to another along a conductor. Electricity is a form of energy that, when in motion, exhibits magnetic, chemical, or thermal effects. An electric current. It is the flow of electricity along a conductor. All materials can be classified as conductors or non-conductors depending on the ease with which an electric current can be transmitted through them. So, a conductor is any material that conducts electricity. Most metals are good conductors. This means that electricity will pass through the material easily. You guys, copper is a particularly good conductor, and it is used in electric wiring and electric motors. Pure distilled water is a poor conductor, but the ions usually found in ordinary water, such as tap water or a river or a lake, make it a good conductor. That explains why you should not go swimming in a lake during an electrical storm. I hope you guys are highlighting everything that you see in the book and putting stars next to everything. Again, that will help you answer your Chapter 7 test. A non-conductor, also known as an insulator, is a material that does not transmit electricity. Rubber, silk, wood, glass, and cement are good insulators. Electric wires are composed of twisted metal threads covered with a rubber or plastic coating. A complete electric circuit is the path that negative and positive electric current takes from the generating source through the conductors and back to the generating source and back again, right? We're on page 185 at the very top. Types of electric current. So we have direct current, abbreviated as DC. It's a constant even flowing current that travels in one direction only, and it is produced by chemical means. Flashlights, cell phones, and cordless tools use the direct current produced by batteries. The battery in your car stores electric energy. Without it, your car would not start. An inverter, you guys, an inverter is a tool that changes direct current to alternating current. Inverters usually have a plug and a cord. They allow you to use appliances outside of the salon, spa, barbershop, right? Or at home that normally would have to be plugged into an electrical wall outlet. The phone charger in a car is an example of an inverter, okay? Alternating current. So, alternating current, abbreviated as AC, is a rapid and interrupted current flowing first in one direction and then in the opposite direction. It is produced by mechanical means and changes direction 60 times per second. Corded hair dryers, curling irons, electric files, and table lamps that plug into the wall outlets use alternating current. A rectifier. So a rectifier, again, it is a tool that changes alternating current to direct current. Cordless electric clippers and phone chargers use a rectifier to change the AC from an electric wall outlet to the DC needed to recharge their batteries. The bottom of page 185, there's a table there, table 7.1, that again, it is talking about the difference between direct current and alternating current. So direct current, constant even flow, travels in one direction, produced by chemical means. Alternating current, rapid and interrupted flow, okay, travels in two directions and produced by mechanical means. Okay. Electrical measurements, we're on page 186. The flow of an electric current can be compared to water flowing through a hose. Without pressure, neither water nor electricity would actually flow. So a volt, abbreviated as V and also known as voltage, is the unit that measures the pressure or force that pushes electric, current forward through a conductor. Car batteries are 12 volts. Normal electric wall sockets that power your tools are usually 120 volts. Most air conditioners and clothes dryers run on 240 volts. A higher voltage indicates more power. Okay? An ampere, abbreviated as A, and also known as an amp, is the unit that measures the strength of an electric current. Just as a hose must be large enough to carry the amount of water flowing through it, a wire must be large enough to carry the amount of electricity that's going to be flowing through it. A hair dryer rated at 12 amps must have a cord that is twice as thick as the one rated at 6 amps. Otherwise, the cord might overheat and start a fire. A higher amp rating indicates a greater number of electrons and a stronger current. Okay, then we have on page 186 a milliampere. Okay, then we have a milliampere, abbreviated as MA, is 1 out of 1,000 of an ampere. The current used for facial and scalp treatment is measured in milliampere. An ampere current will be much too strong if used for facials and scalp treatments. An ampere current would actually damage the skin or the body. An OHM, abbreviated as O, is a unit that measures the resistance of an electric current. Current will not flow through a conductor unless the force volt is stronger than the resistance. Okay. On page 187, a watt, abbreviated as W, is a unit that measures how much electric energy is being used in 1 second. A 40-watt light bulb uses 40 watts of energy per second. A kilowatt, abbreviated as kW, is a 1,000 watts. The electricity in your house is measured in kilowatts per hour. A 1,000 watts, hair dryer uses 1,000 watts of energy per second. Practice electrical equipment safety. When working with electricity, you must always be concerned with your own safety as well as the safety of your clients. All electrical equipment should be inspected regularly to determine whether it is safe for working orders. Careless electrical connections and overloaded circuits can result in an electrical shock, a burn, or even a serious fire. Safety devices. A wire that is not large enough to carry the electrical current passing through, it will overheat. The heating element in a hair dryer or curling iron heats up because it is not large enough to carry the electric current. Heating elements are designed to overheat and are safe when used properly. However, when the electrical wires in a wall overheat, they can cause a fire. If excessive current passes through a circuit or a fuse, the circuit breaker turns off the circuit to prevent it from overheating. These are the electrical safety devices that you may encounter when working in a salon, spa, or barbershop. The first one, a fuse, prevents excessive current from passing through a circuit. It is designed to blow out or melt when the wire becomes too hot from overloading the circuit with too much current, such as when faulty equipment or too many appliances are connected to an electric source. To reestablish the circuit, disconnect the appliance, check all connections and insulation. Insert a new fuse, then reconnect the appliance. Fuses are often found in older buildings that have not been renovated or modernized. A circuit breaker is a switch that automatically interrupts or shuts off an electric circuit at the first indication of an overload. Circuit breakers have replaced fuses in modern electric circuits. They have all the safety features or fuses, but do not require replacement and can simply be reset by switching the circuit breaker back on. A hair dryer has a circuit breaker located at the electric plug that is designed to prevent both professional and clients in case of an overload or a short circuit. When a circuit breaker shuts off, you should disconnect the appliance and check all connections and insulation before resetting it. Grounding. Grounding completes an electric circuit and carries the current safely away. It is another important way to promote electrical safety. All electrical appliances must have at least two rectangular electrical connections or prongs on the plug. This is called a two-prong plug. The two prongs supply electric current to the circuit. If you look closely at the prongs, you will see that one is slightly larger than the other. This guarantees that the plug can be inserted into an outlet only one way and protects you and your client from an electric shock in the event of a short circuit. For added protection, some appliances have a third circuit electric connection that is a grounding pin. This is called a three-prong plug. The grounding pin is designed to guarantee a safe path for electricity and protect the user from electrical shock even if a wire comes loose. Appliances with a third circular grounding pin offer the most protection for you and your clients. This is what a two-prong plug looks like, and this is what a three-prong plug looks like. And I know you guys have seen both of these before. Ground fault interrupters. Please highlight and put a star next to the following. A ground fault interrupter is designed to protect from electrical shock by interrupting a household circuit when there is a leak in the circuit. GFIs are required by the electrical code for receptacles in bathrooms, kitchens, and some outside receptacles. A GFI is designed to detect current of a few milliamperes and trip a breaker at the receptacle's breaker's panel to avoid a shock hazard. When it is working properly, a GFI has a green light that turns red when it trips. Once the appliance is removed from the socket, it can be reset with a reset button on the panel, and that's what they look like. Underwriters Laboratories. Underwriters Laboratories, you will usually see it as UL, certifies the safety of electrical appliances, curling irons, hair dryers, electrical clippers, UV lamps, pedicure chairs, heating mitts, electric files, and more should be UL approved. This certifies that they are safe when used according to the manufacturer's directions. Always look for the UL symbol on electric appliances and take the time to read and follow the manufacturer's directions. Guidelines for use of electrical equipment. Shop fires are often caused by electrical problems such as shorts in the wiring of the building or improper use of appliances, extension cords, and plugs. Careful attention to electrical safety involves following recommended UL guidelines, manufacturer's directions, and the safety instructions and policies of your establishment. The guidelines below will help you use electricity and electrical equipment safely. All the electrical appliances you use should be UL certified. Read all instructions carefully before using any piece of electrical equipment. Always register electrical appliances with the manufacturer so that you will be notified of any safety recalls immediately. Disconnect all appliances when not in use. Pull on the plug, not the cord, to disconnect. Disconnect all electrical appliances prior to cleaning them. Never poke hairpins or wires through any part of the appliance, including lens screens. Inspect all electrical equipment regularly. Keep all wires, plugs, and electrical equipment in good repair. Do not use cords that have exposed wiring in any part of the cord or where it attaches to the appliance. Use only one plug in each outlet. Overloading may cause the circuit breaker to pop. If more than one plug is needed in an area, use a power strip with a surge protector. Avoid contact for both you and your client with water or metal surfaces when using electricity, and do not handle electrical equipment with wet hands or while standing on a wet floor. Keep electrical cords off the floor and away from everyone's feet. Getting tangled in a cord could cause you or your client to trip. Do not leave your client unattended while the client is connected to an electrical device. Do not attempt to clean around electric outlets while equipment is plugged in. Do not touch two metal objects at the same time if either is connected to an electric current. Do not step on or place objects on electrical cords. Okay, what else? Verify regularly that fire extinguishers are appropriate for electrical fires, that are not expired, and that you are comfortable with using one. So again, these are all safety guidelines, all right? What to do in an electrical emergency? We're on page 191. Virtually all electrical incidents in a salon, spa, or barbershop environment will be related to low voltage, less than 500 watts appliances. Low voltage shocks are rarely critical, but they can be quite painful and dangerous to some individuals. It is important that you take signs of wear and tear seriously and replace or discontinue using appliances or outlets as soon as you notice these signs. If you receive a light shock sensation while using, turning on or off, or plugging or unplugging an electrical appliance, stop using the appliance immediately and turn it completely off. Unplug it from the wall or turn it off the circuit breaker to that outlet. Replace the appliance or have it repaired by an authorized repair representative. If similar issues occur with other appliances in the same outlet, discontinue use of that outlet until approved for use by a certified electrician. If you drop an electrical appliance in water, if the outlet is GFI protected, it will kill the circuit immediately and you may unplug the appliance from the wall. After releasing the appliance, you do not have one hand in the water and one at the outlet. If the outlet is still live, your body will conduct the electricity. If the outlet is not GFI protected, go to the breaker box and flip the circuit off. If you are unsure which circuit controls that outlet, it is better to monetarily shut off power to the entire shop while you fix the situation. Once the power is off, unplug the item and then restore your power. Never use an appliance that has been dropped in water. When to seek medical care after an electrical shock. Anytime during pregnancy, if you have burns on the skin, particularly those that are open or do not heal well over time. If you are not current on your tetanus immunizations, given every 5 years to adults. So again, seek medical attention, all right, if it is needed. Identify electrotherapy modalities. The use of electrical current to treat the skin is commonly referred to as electrotherapy. Currents used in electrical facials and scalp treatments are called modalities. Each modality produces a different effect on the skin. I hope you are highlighting and putting stars next to everything you see on my book. This will help you answer your Chapter 7 test questions. An electrode, also known as a probe, is an applicator for directing electric current from an electrotherapy device to the client's skin. It is usually made of carbon, glass, or metal. Each modality requires 2 electrodes, one negative and one positive, to conduct the flow of electricity through the body. The only exception to this rule is the Tesla high-frequency current, which uses a single electrode. Polarity. Polarity refers to the poles of an electric current either being positive or being negative. The electrodes on many electrotherapy devices have one negative charged pole and one positively charged pole. The positive electrode is called an anode. The anode is usually red and it is marked with a P or a plus sign. The negative electrode is called a cathode. It is usually black and it is marked with an N or a minus sign. The negatively charged electrons from the cathode flow to the positively charged anode. If the electrodes are not marked, ask your instructor, manager, or supervisor to help you determine the positive and the negative poles. And here are samples of them. Modalities. The main modality used in beauty and wellness service are galvanic current, microcurrent, and Tesla high-frequency current. Galvanic current. It is constant and direct current, having a positive and negative pole that produces chemical changes when it passes through the tissues and fluids of the body. 2 different chemical reactions are possible with galvanic current depending on the polarity, meaning positive or negative, that is used. The active electrode is the electrode used on the area to be treated. The inactive electrode is the opposite pole from the active electrode. The effects produced by the positive pole are the exact opposite of those produced by the negative pole. Galvanic current is used to infuse water-soluble products into unbroken skin. Iontophoresis is the process of infusing water-soluble products into the skin with the use of electric current, such as the use of the positive and negative poles of a galvanic machine. Cataphoresis infuses an acid, positive product into deeper tissues using galvanic current from the positive pole towards the negative pole. So again, positive pole, also known as an anode, used for cataphoresis, produces acid reaction, closes the pores, soothes nerves, decreases blood supply, contracts blood vessels, hardens and firms tissues. On the negative pole, also known as a cathode, used as anaphoresis, produces alkaline reactions, opens the pores, stimulates and irritates the nerves, increases blood supply, expands blood vessels, and softens tissues. So that is the difference between the two. Again, that is on page 194. Caution, do not use negative galvanic current on skin with broken capillaries or pustular acne conditions, or on clients with high blood pressure or metal implants. Anaphoresis infuses an alkaline negative product into the tissue from the negative pole towards the positive pole. Disincrustation, a form of anaphoresis, is a process used to soften and emulsify grease deposits, meaning oils and blackheads, in the hair follicle. Disincrustation is frequently used to treat acne, milia, and comedones, blackheads and whiteheads. And it usually helps make extractions a little bit easier. Microcurrent. Microcurrent is an extremely low level of electricity that mirrors the body's natural electrical impulses. Microcurrent can be used for iontophoresis, firming, toning, and soothing the skin. It also can help heal inflamed tissues such as acne. Newer microcurrent devices have negative and positive polarity in one probe, not two probes. This allows the client to relax rather than hold on to a probe during the service or treatment. So microcurrent does not travel through the entire body. It serves only the specific area being treated. Microcurrent can be effective in the following ways. It can improve blood and lymph circulation, produces acidic and alkaline reaction, opens and closes hair follicles and pores, increases muscle toning, restores elasticity, reduces redness and inflammation, minimizes healing time for acne lesions, improves the natural protective barrier of the skin, and increases metabolism. When microcurrent is used during aging skin treatment, it may give your client's skin a softer, firmer, more hydrated appearance. Tesla high-frequency current. The Tesla high-frequency current, also known as violet ray, is a thermal or heat-producing current with a high rate of oscillation or vibration that is commonly used for scalp and facial treatments. Tesla current does not produce muscle contractions, and the effects can be either stimulating or soothing depending on the method of application. The electrodes are made from either glass or metal, and only one electrode is used to perform a service. The benefits of the Tesla high-frequency current are: stimulates blood circulation, increases elimination and absorption, increases skin metabolism, improves germicidal action, relieves skin congestion. As you learn more about specific treatments, you'll become familiar with the term contraindication, referring to a condition that requires avoiding certain treatments, procedures, or products to prevent an undesirable side effect. For example, Tesla high-frequency current should not be used on clients who are pregnant or who have epilepsy or any other seizure disorder, asthma, high blood pressure, a sinus blockage, a pacemaker, or metal implants. Additionally, clients should avoid contact with metal such as chair arms, jewelry, and metal bobby pins during the treatment, as a burn may occur if contact is made. Discuss light therapy. The electromagnetic spectrum, also known as electromagnetic spectrum of radiation, is the name given to all of the form of energy that exist. The forms of energy in the electromagnetic spectrum are radio waves, microwaves used in microwave ovens, light waves, infrared lights, visible light, and ultraviolet light used for light therapy services, X-rays used by physicians and dentists, and gamma rays used for nuclear power plants. Energy moves through space in waves. These waves are similar to the waves caused when a stone is dropped on the surface of water. Each type of energy has its own wavelength. The distance between successive peaks of electromagnetic waves, a waveform, is the measurement of the distance between two wavelengths. Some wavelengths are long and some are short. Long wavelengths have low frequency, meaning that the number of waves is less frequent, fewer waves, within a waveform pattern. Short wavelengths have higher frequency because the number of waves is more frequent, more waves, within a waveform pattern. So again, long waves, low frequency, deeper penetration, less energy. Short wavelengths, high frequency, less penetration, and more energy. Please again highlight and put a star next to everything that you are seeing in my book. We're on page 198, visible spectrum of light. Visible light is the part of the electromagnetic spectrum that can be seen. The visible spectrum of light makes up only 35% of natural sunlight. Within the visible spectrum of light, violet has the shortest wavelength and red has the longest. The wavelength of infrared light is just below that of red light, and the wavelength of ultraviolet light is just above that of violet light. Okay, so again, you can see the charts here at the bottom of page 198 in figure 714. So put a star next to where you see it says ultraviolet, shorter wavelength, higher frequency, less penetrating, invisible, 5% of natural sunshine. Although they are referred to as light, infrared light and ultraviolet light are not really light. Ultraviolet light and infrared light are also forms of electromagnetic energy, but are invisible because their wavelengths are beyond the visible spectrum of light. Invisible light makes up 65% of natural sunlight. Okay, so please make sure you are putting stars next to that. Or on page 199 at the top, invisible light. Invisible light is the light at either end of the visible spectrum of light that is invisible to the naked eye. Before the visible violet light of the spectrum is ultraviolet light. It is the shortest and least penetrating light of the spectrum. Beyond the visible red light of spectrum is infrared light, which produces heat. Ultraviolet light, abbreviated as UV light and also known as cold light or actinic light, is invisible light that has a short wavelength, giving it a higher energy, is less penetrating than visible light, causes chemical reactions to happen more quickly than visible light, produces less heat than visible light, and kills some germs. UV light prompts the skin to produce vitamin D, a fat-soluble vitamin that is good for bone growth and health. We need sunlight to survive on the planet. However, overexposure of UV light can cause premature aging of the skin and skin cancer. Incidence of skin cancer has reached a near epidemic level. with over 1 million new cases being diagnosed each year. It is estimated that 1 in 5 Americans will develop skin cancer, and that 90% of those cancers will be a result of exposure to UV radiation from natural sunlight, sun lamps, and tanning beds. There are 3 types of UV light. Let's talk about the first one. Ultraviolet A, UVA. Ultraviolet A light has the longest wavelength of the UV light spectrum and penetrates directly into the dermis of the skin, damaging the collagen and elastin. UVA light is the light that is often used in tanning beds. Ultraviolet B, UVB. Ultraviolet B light is often called the burning light because it is most associated with sunburns. Excessive use of both UVA and UVB light can cause skin cancer. Ultraviolet C, UVC. Ultraviolet C light is blocked by the ozone layer. If the Earth loses its protective layer of ozone, life as we know it will no longer exist. UVC is effective at killing bacteria, viruses, molds, and other pathogens. Infrared light, we're on page 200. Infrared light has longer wavelengths, penetrates more deeply, and has less energy and produces more heat than visible light. Infrared light makes up 60% of natural sunlight. Infrared lamps are used mainly during hair conditioning treatments and to process hair color. They're also used in spas and saunas for relaxation and for warming up muscles. Infrared light has been used to diminish signs of aging such as wrinkles, to heal wounds, and to increase circulation. Light into chemical energy. A catalyst. Catalysts are substances that speed up chemical reactions. Some catalysts use heat as an energy source, while others use light. Whatever the energy source, a catalyst absorbs energy like a battery. At the appropriate time, they pass this energy to the initiator and the reaction begins. Like other chemicals, a catalyst will not get consumed in a chemical reaction. So for example, in hair coloring services, hydrogen peroxide, which is a developer, is the catalyst that allows the hair color to penetrate the cortex of the hair, creating a permanent color. In acrylic nails, for example, the monomer used are the catalyst that solidifies the nail. In the application of gel nails, the UV light is the catalyst for hardening the nail, right? The application of gel. Light therapy. Light therapy, also known as phototherapy, is the application of light rays to the skin for the treatment of wrinkles, capillaries, or pigmentation, or for hair removal. Lasers and light therapy devices have been used for decades, and yet some of the original techniques are still valid today. Lasers are designed to focus all light power to a specific depth and in one direction within the skin, using the same color of light. In contrast, other light therapies have multiple depths, colors, and wavelengths, and the light may be scattered. The most important point to remember about light therapy is that the equipment you use is selected based on the skin type and condition you are treating. All right, you guys, so that concludes Chapter 7, Electricity and Electrical Safety. Please make sure that you do not ignore your glossary that starts on page 202 and ends on page 205. This chapter, it's very important, so whether, I know in this chapter it is referring to barbershop, hair salons, all of that. Again, this book, it is based on obviously is just a general, okay? Anyone in the beauty industry can relate to every chapter in the foundations book, okay? But again, we do work a lot with microcurrent, high frequency, and it is very important for us to know the safety of electricity, okay? So again, do not ignore this chapter. It is important. Go over it more than once so that you're able to retain all of this information, okay? So anywho, this concludes our chapter 7. I hope you found this helpful, and we'll see you guys on the next one.